By the name of God, most merciful, most kind, peace be upon you all, and God's blessing. We are going to have a look to practice problems for permutation matrices quoted from the book of Numerical Analysis by Professor Timothy Sauer. These practice problems are 5, 6, and 7 from chapter 2.4 exercises. Let us have a look to the exercise number 5. Write down a 5 by 5 matrix B such that multiplication of another matrix by B on the left causes row 2 and 5 to be exchanged. Okay, what is the normal position? The normal position of the identity matrix 1, 2, 3, 4, 5, like this. Starting for the first row, starting by 1, all other entries are 0. For the second position, 0, 1, the remaining elements are 0. For the third row, the 1 is in the third row, third column, and the row 4 is expressed as 0, 0, 0, 1, 0. And the final row in the matrix 5 by 5, the 1 occupies the A55 position. Now it is required to shift row 2 and row 5 to be exchanged. So 1 remains as it is, 2 will become 5, 3 remains, 4 remains, 5 become 2. So guided by the arrangement of the identity matrix, I need to swap to 5. So this is 2, swap to 5, 1, 2, 3, 4, 5. Here, that is highlighted. This is 5. 1 remains as it's 1, 0, 0, 0. 3 remains as it exists in the identity matrix 0, 0, 1, 0, 0. 4 remains 0, 0, 1, 0. And 2 become 5. This is 0, 0, 0, which is highlighted by this one. Okay. Assume any numbering. Let us consider the matrix 5 by 5 to the right of the permutation matrix. This is A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y. Once we have 1, 0, 0, 0 in the identity matrix, it is the same. So we expect that A, B, C, D, E to remain as it is. Placing 0, 0, 0, 0, 1 will bring the last row to the second position. The third row remains, the fourth row remains, and the second column will come to the end. Second row will become as a fifth after multiplication. Let us check multiplication of 0, 0, 0, 1 by FGH. Okay? Multiplying this one will meet the U, so we have a U here, and it will meet the V, it is here. Multiplication by the third column, this one will be multiplied by W, so it is here. And multiplying second row by the fourth column, the 1 will be multiplied by X, it will become here. And this one will be multiplied by Y, and it will become here. Likewise, when we multiply 0, 1, 0, 0, 1 by the first column, the F will become here. By the second column, the G will become here. Other zeros multiplication will lead to 0. 1 by H, it will be here. 1 by I, it will be here. And 1 by J, it will be here. Okay, we will move to the next exercise number 6. Write down 4 by 4 matrix P such that multiplying the matrix on the left by B causes the second and fourth rows of the matrix to be exchanged. This is part A, while part B What is the effect of multiplying on the right of B? Demonstrate with an example. Okay, we have 4 by 4 matrix, and the identity matrix for 4 by 4 is 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. And to double check that we have only 1 1 and the remaining zeros for all the columns and all the rows. Okay, this is the normal position B1 2 3 4. What is required? Cause the second and fourth to exchange. So B1 remains 1, 2 will become 4, 3 remains, and 4 becomes 2. Okay, we will bring the first row here, 1 0 0 0, followed by the fourth, which is 0 0 0 1, highlighted. Third remains 0 0 1 0, and the second will be brought to be the last 0 1 0 0 as highlighted. Let us assume that we have the other matrix on the right having the elements 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. 1 0 0 will keep 1 2 3 4 as a row, while 0 0 0 1 will bring the last row to become the second. So the 13, 14, 15, 16 will be here. And 5, 6, 7, 8 will move down to become here. This 0, 0, 1, 0 will keep the 9, 10, 11, 12 here as third row. If you want to examine, let us have a look. If you multiply this one by the first column, all zeros multiplication will lead to 0, plus the 1 by 13, we have 13. By the second column, we have 1, 14, remaining elements multiplied by 0. The third column will multiply 1 by 15 is here, and the last column, 1 multiplied by 16 is here. If we move down to the fourth row, we have 1 multiplied by 5, all the remaining zeros, so we have 5. 1 multiplied by 6 is here. 1 multiplied by 7 is here, and 1 multiplied by 8 is here. The others, first row and third row, remains as is. This is part A. In part B, he said, what happens if we use the same matrix, 1, 4, 3, 2, we multiply, we keep A at the left, but we will keep the permutation matrix on the right side. What happened that the permutation matrix will exchange the columns. As we know, the normal column 1 0 0 0 is the same. It should be followed by 0 1 0 0, the normal position as C1 2 3. Let us write it like this. The normal position, we keep permutation. Let us call it C1 2 3 4. So we have 1 0 0 0, followed by 2 0 1 0 0, followed by 3 0 0 1 0, followed by 4 0 0 0 1. If you multiply this matrix, which is identity matrix also, there will be no change, and AI equal to A. But what happened that 1 0 0 0 multiplied by 1 5 9 13, it will lead to the same column. Okay, we'll move B1 4 3 2. This is 0 0 0 1 is the fourth position of the identity matrix, which means that it brings the fourth column to the second column. So the fourth column is brought for 8, 12, 16 here. So I write first column remains from the first case. Last column becomes as second column. Okay. We have 0, 0, 1, 0. This is our case. The third columns will be brought same. It will remain as it is, 3, 7, 11, 15. So third columns remains. And the last case is the case of 0, 1, 0, 0. This will brought the second column to the last column. What was the second column? 2, 6, 10, 14. It will become the last here. We'll move to the last slide. In the last slide, number 7, the example, change 4 entries of the leftmost matrix to make the matrix equation correct. We can see here we have 1, 2, 3, 4, 3, 4, 5, 6, 5, 6, 7, 8, 7, 8, 9, 0. It is multiplied by permutation matrix such that the right-hand side will become like this. We can see that starting in the new matrix, after multiplication of the permutation matrix, we have the third row here, followed by the second row, followed by the fourth row, and this last row, and 1, 2, 3, 4 is the first row. We are going to multiply first the identity matrix 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and 0, 0, 0, 1. One will move to 4. So 1, 0, 0, 0 will be in the fourth position. And 2 remains, so 0, 1, 0, 0. The third one will move. The third 0, 0, 1, 0 will go up to the first position. And the fourth become the third position. This is the fourth, 0, 0, 0, 1. It will become in the third position. So the first one is 1, 0, 0, 1, 0. Second one is 0, 1, 0, 0. The third one is 0, 0, 0, 1. And the fourth one is 1, 0, 0, 0. What happened when we multiply? Let us concentrate on the rows that were changed. This one. When we multiply the first row by the first column, we have 5 here, followed by 6, followed by 7, followed by 8, which is correct. Row 2, same. So we have the same 0, 1, 0, 0. There will be no change. 5, 6, 7, 8, we have already mentioned. So we have 0, 0, 1, 0. When multiplied by the first column, we have 7 here, followed by 8, followed by 9, followed by 0. Finally, the first row becomes the last row. So this is the first row, 1, 0, 0, 0 in the identity matrix. When we multiply by the first column, we get 1, followed by 2, followed by 3, followed by 4, but in the last position. We come to the end of our video. Thanks a lot. God bless you all. Take care. Goodbye.